Welcome to Midnight Science, and tonight, the nearest planet to Earth gets a little lonelier. James Webb looked at Proxima b again, and every new glance narrows the odds of life rather than widening them. Stay with me and settle in. If this calms you, like and subscribe so more quiet nights can find you. Where are you watching from, and what hour is it there? Somewhere above you tonight, if you could stand under a clear enough sky in the right part of the world, there is a single point of red light sitting low against the dark. You would not notice it on your own. It is too faint for that, too small, too quiet against the wash of brighter stars around it. But it is there, and it is closer to you than any other star in the entire sky. That red point is the nearest sun beyond our own, and circling it, unseen, riding through the same darkness, is the nearest planet to Earth that exists anywhere outside our own family of worlds. Hold that red light for a moment. We are going to come back to it many times before this is over. Its name is Proxima Centauri b. The star it orbits is called Proxima Centauri, and the word Proxima is not decoration, it means nearest. Of all the hundreds of billions of stars that fill our galaxy, this one sits closest to us, and the planet that circles it is, as far as we know, the closest planet to our own that we will ever find. Roughly 4.2 light years away. That is the number that started everything. That is the number that made astronomers lean forward in their chairs when the discovery was announced. Because 4.2 light years in the scale of the galaxy is practically next door. Let me try to make that distance real, because a light year is one of those measurements that slides straight through the mind without leaving a mark. Light is the fastest thing there is. In one single second, a beam of light could circle the entire Earth almost 8 times. In 1 second. Now imagine that same beam of light leaving the surface of Proxima Centauri b, traveling at that impossible speed, never slowing, never resting, crossing the empty dark between the stars. It would travel for more than 4 years before it reached your eyes. 4 years of moving at the speed of light, every second of every day, without pause. That is how far away the nearest planet is. Let me put it in a shape your body understands. Imagine you set out to walk there. Imagine a road, impossibly, laid across that vacuum. And you begin walking at an ordinary human pace, the pace of a person crossing a field on a slow evening. You would not arrive in your lifetime. You would not arrive in 1,000 lifetimes. You would not arrive if every human being who has ever lived walked the road one after another, generation handing the journey to generation. The walk would outlast the species. That is 4.2 light years. The nearest planet, and still a distance that swallows all of human history without noticing it past. And yet, compared to everything else out there, it is close. That is the strange double truth we begin with tonight. Proxima Centauri b is unreachably far and impossibly near at the same time. Both of those things are true, and they do not cancel each other out. They sit side by side. It is the nearest planet we have ever found, and it is still so distant that no ship we have ever built could reach it, and no ship we know how to build could reach it either, not in any span of time that would mean anything to the people who launched it. Now here is the fact that made this small red world into the most watched planet outside our solar system. Proxima Centauri b does not just happen to be nearby. It sits inside what astronomers call the habitable zone of its star. And that phrase carries an enormous weight. So let me set it down gently and tell you exactly what it means and exactly what it does not. The habitable zone is the band of space around a star where the temperature is right for liquid water to exist on the surface of a world. Not too close, where any water would boil away into vapor and be lost. Not too far, where any water would freeze solid and stay frozen. A narrow ring, a temperate lane, where a planet could in principle hold oceans, hold rivers, hold rain. Proxima Centauri b orbits inside that lane, and because liquid water is the one ingredient that every living thing we have ever known depends upon, a rocky planet sitting in the habitable zone of the nearest star is about the most promising address you could possibly imagine in the search for a second living world. You can feel why the excitement was so immediate. The nearest star, a rocky planet, roughly the mass of Earth, sitting in the zone where water could be liquid. For a while, in the first flush of the discovery, it seemed as though the universe had placed its most tantalizing possibility as close to us as it could reach, as if to say, "Look, here, start here." But I want to slow us down now, because this is where the quiet turn begins. This is where tonight's story starts to bend away from the version you might expect. The habitable zone is a label about temperature. That is all it is. It tells you that a planet sits at the right distance from its star for water to be liquid, if that water is there, and if there is an atmosphere to hold it, and if a great many other things have gone right across billions of years. The phrase habitable zone does not mean habitable. It does not mean inhabited. It does not promise life, or air, or oceans, or even a single drop of water. It is a statement about where the planet is, not about what the planet is. A world can sit squarely in the habitable zone and be a scorched rock. A world can sit in the habitable zone and be a frozen stone stripped bare. The zone is an invitation, not a guarantee. It marks a place where life is not immediately forbidden. It does not mark a place where life is assured. Let that land for a second. The habitable zone is a location, not a promise. And closeness, too, is not what it first appears. When the discovery was announced, a great deal was made of how near this planet is, and rightly so, because it is near in cosmic terms. But near does not mean reachable, and it does not mean knowable. 4.2 light-years is close enough to fire the imagination, and far enough to defeat every instrument of exploration we possess. We cannot go there. We cannot send anything there that would arrive while anyone now living still breathes. All we can do is look. And looking across 4.2 light-years at a small, dim planet pressed up against the glare of its own star is one of the hardest things that astronomy has ever tried to do. So consider the human effort that even makes this possible. For centuries, patient people have been mapping this corner of the sky. Long before anyone knew there was a planet here, astronomers had catalogued this faint red star, measured its slow drift across the heavens, calculated its distance, learned that it was the nearest of all our stellar neighbors. Generation after generation added to the ledger. Someone measured. Someone else refined the measurement. Someone built a better instrument and looked again. The knowledge accumulated the way sediment accumulates, one patient layer at a time, most of it laid down by people who never lived to see what it would become. And then, At last, using techniques those early astronomers could not have dreamed of, someone detected the tiny gravitational tug of a planet pulling on that star, and Proxima Centauri b stepped out of the dark and into our awareness. That is the enterprise you are part of tonight, simply by looking up. A long, slow, collective act of attention, stretched across lifetimes, aimed at understanding a place none of us will ever touch. And here is the guiding tension of everything we are about to walk through, so let me set it in front of you clearly, because it is the spine of the whole night. Every time we have looked at this planet more closely, the news has gotten quieter, not louder, quieter. Every fresh, sharper look has narrowed the odds that anything lives there, rather than widening them. Each new measurement, each better instrument, each more careful study has tended to close doors rather than open them. The story of Proxima Centauri b, told honestly, is not a story of mounting hope. It is a story of hope, slowly, gently, being asked to make room for something harder. This is not a tragedy. I want to be careful about that from the very start. There is nothing sad about learning the truth of a place. But it is a turning, and it runs against the direction we usually expect these stories to run. We are used to the search for life beyond Earth being a story of growing possibility, of the net widening, of more and more worlds joining the list of maybes. And for a long time, Proxima Centauri b was near the top of that list. It was the closest maybe we had. Then we built the most powerful eye that human beings have ever lifted above the atmosphere. A telescope so sensitive it can read the faint chemical fingerprints of planets trillions of miles away, so patient it can stare at a single point of light for hours to gather what it needs. And we pointed it, among all the worlds it could examine, at this one, at the nearest planet. We pointed it at Proxima Centauri b, hoping, quietly, that it would bring back good news, that it would find the signature of an atmosphere, that it would widen the door that had been slowly narrowing, and instead, look by look, it kept returning something quieter and heavier than we had hoped. Not a single dramatic verdict, not a slammed door, something gentler and, in its own way, more final. A slow accumulation of silences, each one narrowing the odds a little further. We will walk through all of it. We will stand beside the star and feel how violent a small sun can be. We will cross the divided face of a world that may never turn. We will sit inside the silence that the telescope brought home and learn what a silence can and cannot tell us. And we will come, at the end, to why we keep looking anyway, and why the answer, even a disappointing answer, is worth more than the not knowing. But for now, stay with the beginning. Stay with the red point of light, low on the imagined horizon, the nearest sun in all the sky. And stay with the small world circling it, the nearest planet to your own, riding through the dark exactly as it has for billions of years, indifferent to whether we ever understood it. It is our closest neighbor, and we can see it, faintly, if we know where to look. We can measure it, we can study it, we can point our finest instruments at it, and gather the thin light it sends across 4 years of empty space. We simply cannot go there. We can only look. A neighbor we can name and see, and never, ever visit. Now, settle in, because we have a great deal to unpack. Let us go to the star itself now. Let us leave the planet for a while and turn toward the red point of light it circles, and let us look at it closely, because to understand what has happened to the hope we placed in Proxima Centauri b, you have to understand the nature of the fire it huddles beside. When you picture a sun, you almost certainly picture our own. You picture something vast and yellow-white, fierce and steady, the great furnace that holds the daylight open and warms the side of your face on a summer afternoon. That is the only star any of us have ever lived beneath, so it becomes the shape of the word sun in our minds. But our sun is not the ordinary kind of star. It is not the standard model. If you could take a census of every star in the galaxy, if you could line them all up and count them, you would find that stars like ours are in the minority. The most common kind of star, the kind that outnumbers all the rest, is smaller, cooler, dimmer, and deep red. Astronomers call them red dwarfs, and Proxima Centauri is one of them. So set aside the picture of our sun for a moment and build a different one. Proxima Centauri is small, not a little smaller, dramatically smaller. If our sun were the size of a large beach ball, Proxima Centauri would be something you could hold in your two hands. It has only a fraction of our sun's mass, a fraction of its width, and a tiny fraction of its brightness. It burns not with that fierce yellow-white glare, but with a low, sullen red glow, the color of an ember rather than a flame. It gives off far less light and far less heat. If you swapped our sun for Proxima Centauri and left the Earth exactly where it is, our world would freeze solid almost at once. The oceans would ice over. The warmth we depend on would simply be gone, because this small red star does not have the output to reach us across the distance our own sun so easily crosses. And this smallness, this dimness, is the first key to the whole story. It explains why the planet sits where it sits. Think about the habitable zone again, that temperate lane where liquid water is possible. Around a bright, hot star, that lane sits far out, at a comfortable remove, because the star pours out so much heat that a planet has to keep its distance to avoid being scorched. But around a dim, cool star like Proxima Centauri, the warmth is so faint that the temperate lane is pulled inward, dragged close, pressed right up against the star itself. To be warm enough for liquid water beside a fire this small, a planet cannot stand at a polite distance. It has to huddle in close. It has to crowd the ember to feel any heat at all. And that is exactly what Proxima Centauri b does. It orbits its star at a tiny fraction of the distance that separates Earth from our sun. Remember the walk we imagined in the beginning, the road across the vacuum that no human journey could ever finish. Now shrink that entire relationship down. Earth sits far from our sun, a long, safe remove. Proxima Centauri b sits so close to its star that it completes a full orbit, a full year, in only about 11 of our days. 11 days to go all the way around. On Earth, a year is a long, slow wheeling through seasons. There, a year is barely a week and a half. The planet races around its little red star on a tight, fast track, pulled in close, because close is the only place warm enough to stand. Picture it in bodily scale. If the star were a small fire burning in the center of a dark room, our Earth would be a person standing near the far wall, feeling only the gentlest warmth reach across the space. Proxima Centauri b would be a person crouched almost on top of the flames, close enough to feel the heat on their skin, close enough that the fire fills their whole sky. That is the posture of this planet, not standing back, leaning in, huddled against a small red fire to steal enough warmth to stay above freezing. And for a while that seemed like a happy accident. A small star, a close planet, the right temperature after all. But here is where the picture darkens. And here is where we meet the signature problem of these small red stars. The problem that has done more than anything else to narrow the odds for this world. Small red stars are not calm. They do not burn with the steady, patient glow you might imagine from something so dim. They are restless. They are violent. They seethe and twitch, and, without warning, they erupt. Let me describe what happens plainly, because the word for it, a flare, sounds gentler than the thing itself. A star is a churning ball of superheated gas laced through with powerful magnetic fields. In a small red star, those magnetic fields get tangled and stressed and knotted, and every so often a knot snaps. When it snaps, it releases an enormous burst of energy all at once. The star suddenly brightens, sometimes doubling or more in brightness in a matter of minutes, and it hurls out a violent wave of radiation. Not just visible light, it throws out X-rays. It throws out ultraviolet light, the same kind of radiation that burns your skin on a bright day, but in quantities beyond anything the surface of Earth ever receives. And along with the radiation, it flings out streams of charged particles, pieces of the star itself blown outward into space at tremendous speed. Our own sun does this too now and then. Our sun has flares, but on our sun they are relatively rare, relatively modest, and they happen far away, so that by the time their energy crosses the great distance to Earth, it has spread thin and mostly washes harmlessly against our protective layers. We get auroras out of it, beautiful lights in the northern sky, a gentle reminder that the sun is alive. Now, change every one of those conditions. On Proxima Centauri, the flares are not rare. They are frequent. This small red star erupts often, sometimes many times in a single day, and every so often it lets loose a superflare, an eruption so powerful it can briefly outshine the star's normal output many times over. And these eruptions do not have a great distance to spread thin across. Remember where the planet sits, crouched almost on top of the fire, leaning in close. When Proxima Centauri flares, the planet is right there, pressed against the star, receiving the full force of the blast before it has any room to weaken. Radiation that would be a distant, harmless flicker at Earth's remove arrives at Proxima Centauri b as a hammer blow, again and again and again. Astronomers have measured this. This is not a guess or a fear. Over years of patient watching, using instruments both on the ground and in space, researchers have monitored this star, waiting through the quiet stretches, catching the eruptions when they came, measuring their size and their frequency. Space-based observatories designed to catch X-rays have recorded the star's outbursts. Sensitive survey telescopes have watched it brighten and settle and brighten again. More recently, arrays of radio dishes working together have caught flares in wavelengths that reveal just how much energy these events carry, and just how strange and powerful the star's magnetic tantrums truly are. Person after person, instrument after instrument, year after year, the same picture has assembled itself out of the data. Proxima Centauri is a flare star, a restless, violent, unpredictable little sun that will not sit still. And here is the cruel symmetry at the heart of it, the both and truth that makes this story so quietly heavy. The very smallness that makes this star so appealing in one way is the same smallness that makes it so dangerous in another. Consider the gift first. Because red dwarfs are small and burn their fuel so slowly, they live almost unimaginably long lives. Our own sun will shine for roughly 10 billion years before it exhausts itself. A small red star like Proxima Centauri will burn steadily for far longer than that, for hundreds of billions, even trillions of years. So long that no red dwarf has ever died of old age in the entire history of the universe, because the universe itself is not yet old enough. In that sense, these stars are the most patient, most enduring furnaces in all of creation. If you wanted a stable fire to warm a world for the almost endless stretch of time that life might need to arise and take hold, a small red star offers something our own sun cannot: time. Vast, deep, oceanic time. That is the gift. Now, the cost. That same smallness, that same slow, deep burn comes wrapped in fury. These long-lived little stars stay magnetically active and violent for enormous spans of their lives, flaring and erupting across billions of years, precisely the billions of years during which any life on a nearby planet would be trying to establish itself. The star offers a world the time it needs and bombards it with violence the whole while. It is steady in its lifespan and savage in its temper. Both of these things are true. They are not in conflict. They are the same fact seen from two sides. The long life and the long violence come from the same source. Let that sit with you for a moment. The most patient star is also the most dangerous. The one that offers the most time offers it under fire. And so we arrive at the first real narrowing of the odds, the first door that begins to swing quietly closed. When the discovery was announced, the headline was warmth. A rocky planet in the temperate zone of the nearest star at the right distance for liquid water. But now look at what that warmth is made of. The planet is warm only because it huddles close. And huddling close means sitting directly in the path of a star that erupts again and again, flooding the planet with radiation and charged particles in doses that would sterilize an unprotected surface and, over time, threaten to tear away the very air a living world would need. The warmth and the violence come bundled together. You cannot have one without the other. To be close enough to this small red fire to stay above freezing is to be close enough to be battered by every eruption it throws. The same posture that keeps the planet from becoming a frozen stone exposes it to a relentless barrage from above. Nothing is decided yet. A planet can be bombarded and still, in principle, endure if it has the right defenses, the right shield, the right thick blanket of air to absorb the blows. We have not yet asked whether Proxima Centauri b has any of that. We have only stood beside its star and felt how violent a small sun can be. But the first door has moved. The warmth we celebrated turns out to come at a price. And the planet sits there, crouched against the ember, feeling the heat, taking the blows, circling its restless red star every 11 days as it has for billions of years, close to a fire that will not stop spitting. Stay with the planet now. Stay with that small, rocky world crouched close to its restless red star, receiving the warmth and the violence at once, wheeling around its orbit every 11 days. We have looked at where it sits and at the fire it huddles beside. Now we have to look at how it turns, because how a world turns, or does not turn, shapes everything about what its surface can be. On Earth, the day is something we take for granted. The planet spins on its axis, and every point on the surface gets carried in turn through sunlight, and then through darkness, sunlight, and then darkness, in a steady rhythm that has been going on for as long as there has been an Earth. The side that faces the sun heats up. The side that turns away cools down. And because the planet keeps turning, no place stays under the sun long enough to bake to death, and no place stays in the dark long enough to freeze forever. The rotation shuffles the warmth. The rotation gives us morning and evening, and the gentle equilibrium of a world that averages itself out. Now imagine a world that has stopped doing that. Imagine a world that turns, in a sense, but turns so slowly, so precisely in step with its journey around its star, that the same face is always pointed inward toward the fire, and the same face is always turned outward toward the dark. Not for a day, not for a year, forever, for the entire history of the planet. That is what astronomers believe has almost certainly happened to Proxima Centauri b. The technical term is tidal locking, and I will explain why it happens. But first I want you to feel what it means, because the feeling matters more than the vocabulary. You already know an example of tidal locking, even if you have never used the phrase. Look up at the moon on a clear night. The moon shows us the same face every single time we see it. The same craters, the same dark seas, the same pattern of light and shadow. The far side of the moon, the side that faces away from Earth, is never shown to us. No human being on Earth has ever seen it with their own eyes. Not one, not ever. The moon rotates, but it rotates in exactly the time it takes to circle us once. So from our vantage, the same hemisphere always looks back. That is a tidally locked world, locked by the gravity of its larger neighbor into a rotation that matches its orbit. The reason this happens is quiet and slow. When a smaller body orbits close to a larger one, the larger one's gravity pulls slightly harder on the near side of the smaller body than on the far side. That uneven pull, applied over and over across enormous stretches of time, gradually drags on the smaller body's rotation, slowing it down, easing it, over hundreds of millions of years, into a rhythm that matches its orbit. Once the two match, the tugging stops trying to change anything, and the body is locked. It keeps one face turned toward its partner from that point on, essentially forever. For our moon, the partner is Earth. For Proxima Centauri b, the partner is that small red star it huddles so close to. And huddling close is exactly what makes tidal locking so likely here. The nearer a world sits to the object it orbits, the stronger the tidal pull and the faster the locking happens. Proxima Centauri b sits so close to its star and has been sitting there so long that astronomers consider it almost certain that the process has already finished. The planet is locked. One side of it faces the star and has faced the star for a very long time. The other side faces the dark and has faced the dark for just as long. Let me walk you across this world, slowly, so that you can feel what a divided planet actually is. Begin on the day side. Stand on the surface at the point directly beneath the star, the place astronomers sometimes call the substellar point. Above you, the red sun hangs in the sky. It does not rise. It does not set. It does not move at all. It sits fixed in one place, low or high depending on where you stand, but always in the same spot, always the same size, always the same sullen red glow. There is no dawn here. There is no dusk here. There is no evening. There is only this. A single unmoving red eye staring down at you from the same patch of sky it has held for billions of years and will hold for billions more. The ground beneath you is warm, warmed continuously by that unblinking star. There is no night to let it cool. Whatever heat the surface has absorbed, it keeps absorbing, day after day after day, in a day that never ends. Depending on how much air surrounds the planet and how thick that air might be, the temperatures on this day side could be anywhere from uncomfortably warm to blisteringly hot. But the essential quality is the same: permanence. A cooked, held, unchanging heat delivered by a sun that does not move. Now begin to walk. Walk in a straight line away from that fixed sun. Walk in the direction where the star begins to sink lower and lower in the sky. As you go, the red glow above you drops toward the horizon. The light around you starts to dim, not because anything is changing in time, but because you are changing in space. You are walking toward the edge of the world's illumination. And after a long, long journey, you would reach a strange and quiet place, a place where the star sits exactly on the horizon, half of its red disk visible and half hidden, held there permanently, neither rising nor setting, simply present. Everywhere on this line, all the way around the planet, the red sun sits at the edge of the sky and stays there. This is the ring of endless twilight, the border between the two halves of the world, a thin band of perpetual dusk that never advances into evening and never retreats into morning. Stand on that line for a moment. Behind you, everything you have walked through is bathed in the fixed red glare. Ahead of you, everything is dark. If you turned around, you would see the star. If you kept going forward, you would step out of the light entirely. So keep going forward. Walk into the dark side. The star drops below the horizon behind you and does not come back. Not in an hour, not in a day, not ever. You are walking now on the night side of the world, and the night side has been the night side since the planet's youth. There is no dawn coming. There is no ordinary way for warmth to reach here from that fixed sun. What heat this side has is only what it can hold on to, or what might drift across from the day side if the planet has an atmosphere thick enough to carry it. Without that atmosphere, the night side is a place of extraordinary cold. Cold beyond what any place on Earth has ever known. Temperatures that would freeze not just water but the very air itself out of the sky, condensing gases into ice on the frozen ground. A permanent, unrelieved dark, held down by a cold that has had billions of years to settle in and stay. That is the shape of a tidally locked world in the harsh case. One face held in a blinding, unchanging red day, another face held in a black and frozen night, and between them, the thin band of eternal twilight where the red sun rests on the horizon forever, neither rising nor setting. Let that land for a second. Now, this is the point where I have to be careful, because it would be easy to close the door here. It would be easy to say that a world so divided cannot possibly hold life, and to move on. But that is not what the science says, and I promised you a night of looking at this honestly, so let me hold both truths. Tidal locking is not automatically fatal to life. It is not, on its own, a verdict, because a world does not have to endure its two extremes forever. If a planet has an atmosphere, air moves. Air carries heat. Winds pick up warmth from the hot day side and blow it around the world. They carry it across the twilight zone. They deliver it into the darkness of the night side, where it warms the frozen ground before returning, cooled, back around toward the light. Ocean currents, if there are oceans, would do the same. A thick enough atmosphere working hard enough could soften the extremes of a tidally locked world dramatically. It could turn a scorching day side and a frozen night side into something more like a warm hemisphere and a cool hemisphere. It could pull the twilight ring wider, blur the divisions, spread the warmth. On a world with a heavy blanket of air, tidal locking might mean strange weather and permanent daylight, rather than a scorched half and a dead half. Life, in principle, could still find a place there, perhaps on the twilight ring, where the temperature is gentle, perhaps beneath oceans that the winds keep from freezing, perhaps in a night side made livable by the constant traffic of warm air moving in from the day. So tidal locking by itself does not close the case. It changes the world dramatically, but it does not decide it. What decides it is whether the planet has enough of an atmosphere to move that heat around. What decides it is whether there is air here at all. And that is the pivot. That is where everything the rest of this night hinges on. Every question about whether Proxima Centauri b could be habitable, whether life could ever have arisen there, whether the surface is a place where anything could survive, comes down now to a single question, quieter and simpler than all the others. Is there an atmosphere? Not just any atmosphere. Not a thin, wispy trace of gas clinging to a mostly bare rock. Something substantial enough to move heat. Something thick enough to soften the extremes. Something dense enough to shield the ground from the stars' flares. The entire case for this world as a place where life might exist, and the entire case for the twilight ring as a place where a living thing could ever have taken hold, rests on one thin, uncertain veil of gas wrapped around a small, rocky planet 4.2 light-years away. Sit with that for a moment. An entire world's possibility, an entire species of hope, an entire question about our nearest neighbor, gathered up and set down on the answer to one measurement. Does the planet have air? And if it does, how much? That is the question that James Webb was pointed at this world to try to answer. That is the reason the most powerful telescope our species has ever built took time in its careful schedule to stare at a small, dim planet crouched beside a small, restless star. Because if the answer was yes, then the divided world could still be a soft world. If the answer was no, or if the answer came back as silence, then the divided world would stay divided, and the case for anything living there would collapse from possibility into memory. And the answer, when it started to arrive, was not what the hopeful part of us wanted to hear. But we are not there yet, not tonight. Tonight we leave the planet here in its locked state, waiting to be measured. One face turned to the star, one face turned to the dark, a ring of twilight running around its middle. and above it all, patient as it has always been, the small red sun burning steady and violent at once, holding the whole strange geometry in place. A world divided. A world in balance only if it has something we do not yet know it has. A world about to be looked at more closely than any planet outside our own has ever been looked at before. And the question it holds, quietly, in its stillness, is whether there is anything at all between the ground and the sky. So we come to the question the whole night has been walking toward. Does Proxima Centauri b have an atmosphere? Is there a veil of gas wrapped around that small rocky world, thick enough to move heat, thick enough to shield the surface, thick enough to give the divided planet a chance at anything but its two extremes? Everything now depends on the answer. And for the first time in human history, we have an instrument capable of asking. Let me tell you about that instrument, because it matters, and because the patience of its design is part of the story. The James Webb Space Telescope is the most powerful eye our species has ever lifted above the atmosphere. It sits far from Earth, out beyond the moon, in a stable point of space where it can hold perfectly still and stare at whatever it is pointed toward for hours or days at a time. It has a mirror wider than any telescope ever launched, folded gold, unfolded once it reached its post, and it is tuned to see in the wavelengths of infrared light, the wavelengths that reveal heat. It was built over decades by tens of thousands of people, scientists and engineers and technicians and quiet workers whose names most of us will never know, and it was launched with a whole world watching, hoping the unfolding would work, hoping the mirror would open, hoping the years of labor would arrive at their moment. And the unfolding worked, and the mirror opened, and the telescope, at last, began to see. Among the many things it was designed to do, one task was to look at planets around other stars, and to try to read the fingerprints of their atmospheres. That is a remarkable sentence, so let me slow it down and tell you what it actually means, because the technique is more delicate than it sounds. When starlight passes through a planet's atmosphere, or when heat rises off a planet's surface and travels back out into space, the gases in the atmosphere leave their marks on the light. Different gases absorb different colors, different wavelengths, different specific bands of the spectrum. Carbon dioxide leaves one kind of imprint, water vapor leaves another, methane leaves another. Oxygen, nitrogen, ozone, each has its own signature, its own pattern of absorption, its own way of quietly bending the light that passes through. If you can catch that light with a sensitive enough instrument, and if you can spread it out into its component colors carefully enough, you can read the pattern like a language. You can look at the dips and the notches and say, there is water, there is carbon dioxide, there is a whole atmosphere here, and this is what it is made of. That is how James Webb searches for air on other worlds. It watches the light and it watches the heat and it looks for the fingerprints. It listens, in a sense, for the signal a gas would leave if a gas were there. And it was pointed at Proxima Centauri b to listen for exactly that. Now, the way this listening happened was not one single dramatic look. It was not a single glance that returned a single verdict. It was a set of careful observations, spread out, each one designed to test a particular question. Astronomers pointed the telescope at the star and watched. They watched the heat coming off the planet as it moved through its orbit, looking for signs that warmth was being carried from the hot side to the cold side, the way an atmosphere would carry it. They watched for the specific fingerprints of the gases they expected an atmosphere might contain. They collected the light patiently, hour after hour, and they took it home to their computers, and they processed it, and they looked to see what the telescope had brought them. And the answer, gathered across those looks, did not arrive as a shout. It arrived as an accumulation of quiet. It arrived as absence. There was no clear signal of an atmosphere, not one that could be pointed at and named, not a fingerprint that rose above the noise and said, "Here I am," not a burst of carbon dioxide or a splash of water vapor, not the pattern of heat being carried around the planet the way it would be if a thick blanket of air were doing the work. The looks came back, and what they came back with, again and again, was a great, patient silence where the signal should have been. Let me be careful here, because a silence in science is a difficult thing, and it can mean more than one thing at once. I want to hold this honestly with you. The absence of a signal is not the same as the absence of an atmosphere. It is important to say that clearly. Sometimes a signal is too faint for even the best instrument to catch. Sometimes the geometry of the observation is not quite right. Sometimes the atmosphere is there but is thin, or made of gases that leave weaker fingerprints, or hidden beneath clouds that flatten the light and mask what lies below. A non-detection is not, by itself, a verdict of nothing. It is a verdict of we could not find it. It is a verdict of if it is there, it is not the kind of atmosphere we would have expected to see easily. That distinction matters. It is the epistemic humility the science demands. We looked and we did not find. We did not prove that there is nothing there. We proved that if there is something there, it is not thick, not obvious, not shouting. And yet, when you put that silence beside everything else we have already walked through tonight, the meaning of the silence begins to sharpen. Remember the star. Remember the small red sun that will not sit still. Remember the flares that erupt again and again, hurling out X-rays and ultraviolet light and streams of charged particles at a planet crouched only a fraction of Earth's distance away. Remember the billions of years across which that bombardment has been going on. And now, let me tell you what a bombardment like that does to a planet's air. An atmosphere is not a fixed thing. It is not a stone shell wrapped permanently around a world. It is a fragile, mobile, drifting envelope of gas held to the planet only by the planet's own gravity. And gravity is a modest force. If something pushes hard enough on the top of the atmosphere, molecules of air can be pushed away entirely, given enough energy to escape the planet's grip and drift out into space, never to return. Once they are gone, they are gone. There is no getting them back. That is what a flaring star does, over time, to a world too close to it. The bursts of high-energy radiation heat the top of the atmosphere and puff it outward. The streams of charged particles hit that puffed-up atmosphere and blow pieces of it away. Molecule by molecule, layer by layer, the air is stripped. And on a world without a strong magnetic field to deflect those charged particles, the stripping is even more efficient, because there is no shield to divert the wind that scrapes the air away. Our own planet has a magnetic field, a powerful one generated deep in Earth's molten core, wrapping our world in an invisible shell that catches the sun's charged particles and turns them aside before they can reach the atmosphere. That shield is one of the quiet reasons we are still here. It is why our atmosphere has lasted, why our oceans have not been blown away, why the sun's constant weather does not slowly erode our air across the ages. We do not know for certain whether Proxima Centauri b has such a shield. There is no direct evidence that it does, and even if it does, the flares it endures are so much stronger than anything Earth ever faces that a modest shield might not be enough. Models of what would happen to an Earth-like atmosphere placed at Proxima b's orbit suggest that the air would not survive. It would be stripped away, slowly and then not so slowly. Across the billions of years the planet has been sitting there. Every flare, a small subtraction, every stream of charged particles another sip taken from the top of the sky. Across time, the sip becomes a swallow, and the swallow becomes an emptying. So put the two pieces together. A telescope looks and finds no clear signal. A star flares and erodes any air a small close planet might hold. The silence, on its own, is not proof. Combined with the star, the silence begins to fit into a picture that has been forming for years. A picture of a world that once might have had an atmosphere, or might have started with one, but has been slowly scraped bare across the long violence of its neighborhood. Sit with that for a moment. The silence could mean the telescope did not look long enough. The silence could mean the atmosphere is thin and hidden. The silence could mean clouds obscured what was there. The silence could mean we asked the wrong question, in the wrong way, at the wrong time. The silence could mean the fingerprints are of gases we did not expect. All of those remain possible, and honest science holds them open. The silence could also mean there is nothing there. It could mean the small red star has done its slow work, and the planet has lost whatever air it ever carried, and it circles now as a bare and battered rock, its dayside baking under the fixed sun, its nightside frozen in unrelieved dark, no wind to move heat from one to the other, no shield to soften the flares, no chemistry to build a chance of anything. Just stone and radiation and the two extremes, held apart forever with nothing between them. That is the possibility the silence points toward when you set it beside everything we already know. Not certainty, never certainty, but a weight leaning that way, growing heavier the longer we look and the more silence we gather. And it is worth pausing here to feel what that means, because we have come to the emotional floor of this story, and I do not want to walk past it too quickly. For a while, the nearest planet to Earth was a promise. It was the closest possible home for something living beyond our own world. It was the first place a distant neighbor might have looked back. It was, in the imagination, a candle in the window across an impossible distance, a small, warm proof that we are not the only lit house on the street, and every fresh look has dimmed that candle a little more. There may be no neighbor waiting there. There may be no wind moving across a twilight ring. There may be no oceans on the dayside slopes catching the fixed red sun in gentle waves. There may be no anything, just a small stone close to a small star, orbiting in silence, receiving flare after flare into a sky that has almost nothing left to catch them with. The nearest planet, and possibly one of the emptiest. The isolation of that is real. It is worth naming, because for a moment, when you let it settle, the sky feels a little larger and a little more lonely. The nearest place we could hope for turns out, most likely, to be a place where hope was always going to lose to physics. Let that land for a second. But I want you to notice something too. Notice that the silence, even at its heaviest, is not the end of anything. Notice that we are still here, still looking, still learning. Notice that the telescope did not go dark when the answer came back quiet. It kept going. It turned toward other worlds. It gathered more light. It listened elsewhere. And notice that Proxima Centauri b itself is not changed by what we have learned. It is exactly what it has been for billions of years, exactly what it was before we pointed our instrument at it, exactly what it will be long after we have turned our attention somewhere else. The learning is on our side. The rearranging is in our minds. The planet keeps its own reality, whatever that reality turns out to be, and we are the ones who have to make room for it. So the silence sits with us tonight, not as a verdict, but as a weight, not as a door slammed, but as a door drifting quietly closed. The nearest world may be a bare rock. The nearest world may hold a thin secret we have not yet caught. We do not know for certain. We only know what the light has told us so far, and what the light has told us so far is a quiet that leans toward emptiness. And still the planet turns, and still the star flares, and still the telescope, out beyond the moon, waits to be pointed at whatever we ask it to see next. So we sit with the silence, we let it settle, we let the weight of it register, and then, slowly, we begin to turn. Because a silence like this one, gathered patiently by the finest instrument our species has ever built, aimed at the nearest planet in all the sky, is not the failure it might feel like at first. It is not a defeat. It is not even, really, a disappointment. Once you look at it properly, it is something else. It is knowledge. It is the hard, honest, quietly given answer to a question that generations of people wondered about without any hope of ever hearing a reply. Let me try to say what I mean. For thousands of years, human beings have looked up at the night sky and wondered whether we are alone, whether there is anyone out there, whether some other patch of ground somewhere carries some other kind of life, looking back at their own stars, wondering the same thing about us. For most of that history, the question had no way to be answered. It was a question you could only ask, and then sit with, and then set aside, because there was nothing you could do with it. You could not look closely enough. You could not reach anywhere. You could not test anything. The nearest star was a smear of light, and the planets around it, if there were any, were beyond anything the mind could confirm. The question hung in the air, generation after generation, and each new generation inherited it and passed it down, unresolved. Then, slowly, over the last few centuries, and then dramatically, over the last few decades, that began to change. Instruments improved. Techniques were invented. People learned how to detect the tiny wobbles of stars caused by planets pulling on them. People learned how to catch the faint dimming of light when a planet passed in front of its sun. One planet became 100, 100 became 1,000, 1,000 became many thousands. The universe filled in around us, and we discovered that planets are everywhere, around every kind of star, in every corner of the sky, not rare, not exotic, everywhere. And among those thousands of discoveries, one stood out, the nearest one, Proxima Centauri b, the closest of all the possible addresses, the one that made the question feel, for the first time in our history, urgent and near and answerable, not decades of hoping, not millennia of wondering, a specific world at a specific address, that we could point a telescope at and try to read. We built the telescope, we pointed it, we listened, and what came back was quiet. That quiet is not nothing. That quiet is the first honest answer any human being has ever received to a specific version of the oldest question. It is the first time we have been able to look at a particular planet, our nearest, and gather real evidence about what it is like. Not guessing, not modeling, not extrapolating, looking, and the fact that the looking returned a quiet answer rather than a loud one does not diminish the achievement of being able to look at all, it sharpens it. Because a clear no, or something leaning toward a clear no, is worth more than 1,000 comforting maybes. A clear no is data, a clear no lets us move. Think about what generations of astronomers would have given, quite literally would have given anything, for even 1 hour of the kind of clarity we have now. To know something specific about a specific planet around another specific star. To know it not by guessing but by measuring. The people who first calculated the distance to Proxima Centauri, who noticed its faint drift across the sky, who added it to the catalogues and passed those catalogues down, would have wept to sit where we are sitting tonight. Not because the answer was cheerful, because there was an answer at all. Because the question, at last, was being addressed by evidence. That is the first thing worth holding. The silence is not a failure of the instrument or the effort. The silence is the sound of a question being answered honestly for the first time. The second thing worth holding is what the silence teaches us about the wider search. Because Proxima Centauri b is not just one planet. It is a lesson, and what it is teaching us is going to shape how we look at every other world for a long time to come. For a while, the way we search for possible living worlds was simple. Find a rocky planet, check whether it sits in the habitable zone, add it to the list. That was the rule. That was the shortcut. Rocky, temperate, in the zone, promising. And Proxima Centauri b fit every part of that shortcut cleanly. It was rocky, it was roughly Earth-sized, it was in the habitable zone. By the old rule, it was one of the most promising worlds we knew. But now we have looked closely, and we are learning that the old rule was not enough. That closeness and the habitable zone label, on their own, are not the same as habitability. That a world can sit in the temperate lane and still be a bare rock if the star it orbits is too violent, or if the planet is too small to hold its air, or if the geometry of its rotation locks it into extremes that only an atmosphere could soften, and the atmosphere is not there. What Proxima Centauri b is teaching us is that being in the habitable zone is a necessary condition and not a sufficient one. It is the beginning of the question, not the answer. To ask whether a planet could actually hold life, you have to ask about the star. Is it calm, or does it flare? You have to ask about the planet's rotation. Is it locked? And if so, how divided? You have to ask about the atmosphere. Is there one, and how thick, and made of what? You have to ask about the magnetic shield, and the history of the system, and the way the star behaved when it was young and violent, and whether anything the planet started with could have survived the long, slow scraping of billions of years. Every one of those questions is now part of the checklist, in a way it was not before. The search has grown more careful. The search has grown more honest. The search has grown, in a real sense, better. And that improvement was paid for by the silence we heard tonight. by the willingness to point our best instrument at our nearest neighbor and to accept the answer, whatever it was. That is a gift. It is a gift for the search, and it is a gift too for every future planet we will consider, because now we know how to consider them more carefully. There is a third thing worth sitting with, and it is quieter than the others, but I think it is the one that matters most. Imagine, for a moment, that you could stand on Proxima Centauri b. Imagine that everything the science suggests is wrong, and there is an atmosphere after all, thin and precious, and there is a surface you could stand on, and there is a horizon you could look toward. Now imagine you turn your face away from the fixed red sun, and you look up into the dark side of the sky, and you look for our own sun among all the tiny points of light scattered across the black. You would find it. It would be there, small and yellow-white, just another star in the crowd, unremarkable in its little patch of sky. And if there were someone standing beside you, some imagined neighbor, some possible observer, they might point to it and know that around that particular star there was a small blue and green world, and that on that world there were beings looking back. There is almost certainly no such observer. There is almost certainly no one standing on that surface, looking up, picking out our sun from among the thousands. The night we have walked through tonight has made that clearer than it has ever been. The nearest planet is, in all likelihood, empty of anyone who could look back. And yet, even the absence sharpens something. Even the imagined observer who is not there, who almost certainly never was there, tells us something by their absence. They tell us that the question of whether we are alone is a question about specific places, not about vague hopes. That, when we ask, "Are we alone?" we are asking about actual planets, actual atmospheres, actual chemistries. And when a particular planet, our nearest, quietly turns out to be the kind of place that could not sustain that answer, our loneliness becomes slightly more specific, and slightly more real, and slightly more worth attending to. That is not a sad thought, not exactly. It is a clarifying one. The universe is not full of easy neighbors. The nearest one, the one we most wanted to be there, appears not to be. The question of whether anyone else exists somewhere further out remains open, but the question has grown more serious, and the answer, whatever it turns out to be, will have been earned by looking at worlds like this one and taking the honest measure of what they are. And this brings me to the fourth thing, the one I most want you to carry with you, the dignity of the looking itself. Consider what actually happened here. Human beings, working across many decades, on many continents, in many institutions, built an instrument together. Tens of thousands of them. Scientists and engineers and technicians and welders and machinists and coders and clerks and administrators. Almost none of them will ever be famous. Most of their names will never be attached to the discoveries their work made possible. And yet they built it. They built the mirror and folded it and unfolded it. They built the instruments and calibrated them and tested them 1,000 times. They launched it into space and shepherded it to its post and coaxed it into its careful stillness, and then they pointed it at the nearest planet. Not because they were sure they would find good news, not because the discovery was guaranteed to be triumphant, but because it was the honest question to ask, and because they had built an instrument capable of asking it, and because our species had reached the point in its history where we could look, and so we should look, because looking is what we do, because looking patiently at the actual sky is one of the finest things we know how to do. They pointed it, they gathered the light, they took the answer, whatever the answer was, and they made it available to the rest of us, not as a triumph, not as a headline, as a fact, as a small, precise, hard-won piece of truth about a small world 4.2 light-years away. That is worth honoring. That is the dignity at the center of this night. The dignity of looking, the dignity of asking a real question and being willing to accept a real answer. The dignity of preferring an honest quiet to a comforting rumor. That is what our best instruments are for. That is what our best people are for. That is what we are for when we are at our best. And so we can hold two things now, together, without contradiction. Proxima Centauri b has grown less likely to be alive. That is true. Every honest look at it has narrowed the odds. Every measurement, every observation, every quiet return of no clear signal has pushed the case for life on this particular world further from the possible and closer to the unlikely. That is the direction the evidence points, and it is worth acknowledging that direction plainly. And at the same time, Proxima Centauri b has grown more valuable to us as a lesson. It has taught us to look more carefully. It has taught us to widen our checklist. It has taught us to respect the difference between a location and a promise, between a habitable zone and a habitable world, between being in the right place and being in the right condition. It has given us, through its silence, the first honest baseline against which every other exoplanet we study will now be measured. It has moved the science forward quietly, patiently, exactly the way real science moves. Both of these are true. The planet grows less alive and more instructive at the same moment. The two facts are not in tension, they are the same fact, seen from two sides. And there is something worth resting in there, something like the beginning of peace. Because the awe we came in with tonight, the awe of the nearest planet, does not have to disappear just because the answer has grown quieter. The awe can settle into a different shape. Not the awe of the maybe, but the awe of the actual. Not the awe of what we hoped for, but the awe of what we can now know. Not the awe of a possible neighbor, but the awe of the fact that we have looked hard enough to speak, however tentatively, about that neighbor at all. That is a different kind of awe, and it is a steadier one. It does not depend on the answer being cheerful. It depends only on the question being asked, and being asked well, and being answered honestly. The universe becomes no less wondrous when we learn that one of its worlds is probably empty. It becomes in its own way more so, because we have looked and we have learned, and the looking and the learning are themselves part of the wonder. So the night bends, gently, from the low place towards something quieter and more settled. The silence is still there. The planet is still there. The star is still flaring. The divided world is still turning slowly on its locked axis. One face to the fixed red sun, one face to the dark. Nothing on that surface has changed while we have been talking. Nothing on that surface will change tomorrow, but something in us has moved a little. We have carried the honest weight of what the looking has returned. We have made room for a nearest neighbor who is probably not there. We have sharpened the question of aloneness into something more specific and more earned. We have honored, quietly, the long patient labor that made any of this knowable at all. And we have chosen, together, to prefer the quiet truth to the comforting rumor. That is not a small thing. That is one of the finest things a species can do. So let the weight ease a little now. Let the sentences soften. Let the pace slow, the way an evening slows when the last of the light drifts down and the room begins to fill with dusk. There is nothing more to prove tonight. There is nothing more to argue. There is only the walk back to where we began, and one more look at the red point of light low on the imagined horizon, and one last quiet thing to say about our nearest and quietest neighbor. Come with me for that. It will be gentle. It will not take long. Before we walk back to the anchor image, before we return to that single red point of light low on the imagined horizon, I want to widen the frame with you for a while. I want to take you gently out beyond Proxima Centauri b, out past the small red star it huddles against, and show you the larger family that both of them belong to. Because our nearest neighbor is not, as it turns out, a strange and isolated case. It is one member of a very large and very quiet family, and what we have learned about it is beginning to fit into a pattern that touches many other worlds beyond it. Let me start with the stars themselves. When you picture the galaxy in your mind, if you picture it at all, you probably imagine it full of stars like our own sun, bright, yellow, white, steady. That is the shape the word star takes for most of us, because our sun is the only star we have ever lived beneath, and it has trained our imaginations to think that its kind is the ordinary kind, but it is not. If you could somehow tally every star in the Milky Way, if you could count them one by one and sort them by size and temperature, you would find that stars like ours are outnumbered many times over. The most common kind of star in the entire galaxy, by a large margin, is small and cool and red, the small red dwarfs, the little sullen embers. Something like 3 out of every 4 stars in the galaxy belong to that family, perhaps even more. They are the quiet majority. They are the small red suns that populate almost every corner of the sky, most of them too faint to see with the naked eye, most of them going about their long, slow lives without any of us noticing them at all. Our own sun sits inside a minority of larger, brighter, hotter stars. It is not the standard. It is a comparatively rare thing in this galaxy to be born beside a sun like ours, which means something important for the search we have been walking through tonight. If we want to find the nearest habitable world beyond our own, the nearest place where life could plausibly have taken hold, we are almost certainly going to be looking for it around a small red star. Not because the small red stars are the best hosts, but because they are the most numerous, and because so many of them sit close enough to us that we can actually study the planets around them. When astronomers scan the neighborhood of the Sun, the nearby handful of light years, they find red dwarfs everywhere. Nearly every star within a few light years of Earth is one. Proxima Centauri is one. Our second nearest stellar neighbor is a pair of red dwarfs, our third, our fourth. Almost all of them, until you go quite far out, are small red suns. The nearest possible living worlds, if they exist at all, are almost certainly crouched close to little restless fires, like the one Proxima Centauri b crouches beside. That is the shape of the wider search, Not a scattered hunt across many kinds of stars, but a focused study of a specific kind of star and a specific posture that planets have to take beside it. Close in, locked in place, sitting inside the habitable zone that these dim suns pull tight against themselves. The nearest neighbors, if we have any, live in postures that look very much like the posture of Proxima Centauri b, and that means what we learn about one of these worlds is, in a real sense, learning about many of them. The patterns we see in one are worth watching for in the others. The silences we gather from one are worth setting beside the silences we gather from the others. This is how science quietly does its work, not through a single dramatic reveal, but through the slow assembly of many small findings into something that begins, at last, to look like a picture. Let me tell you about another system now. Another red dwarf, not so far from us in the scale of these things, close enough that we have studied it carefully. This particular star holds a tightly packed family of small rocky worlds, 7 of them, all crowded in close, all racing around it on tight, fast orbits, several of them sitting inside what we call the temperate lane, the habitable zone. It is a remarkable configuration. 7 small stones circling one small red sun, some of them possibly warm enough for liquid water if the conditions were right, some of them possibly too hot, some of them possibly too cold, but several sitting squarely inside the band where, in principle, a rocky world could hold oceans if it had the atmosphere to hold them with. When this system was first announced, some years ago now, the excitement was enormous. Not one candidate, but several, all around a nearby star, all rocky, all in the right sort of place. It seemed as though a whole small solar system had been arranged for the specific purpose of teaching us about the habitability of small worlds close to small suns. And when the great telescope beyond the moon was ready, it was pointed at those worlds too, not just at Proxima Centauri b, at the tightly packed family as well. Careful looks, patient observations, the same kind of listening, the same kind of watching the light and the heat for the fingerprints of gases that would tell us whether atmospheres were there. And what the telescope brought back from those looks was, for the most part, the same kind of quiet. The innermost planets in that packed family, the ones closest to their small red star, returned observations that pointed toward little or no atmosphere. The heat coming off their day sides looked like the heat that would come off a bare, dark rock, warmed only by the sun above and unable to move that warmth around to any other part of the world. The specific fingerprints that a thick atmosphere would have left in the light were, again, not clearly there, not a shout, a quiet, the same kind of quiet. Not every world in the family has spoken yet. Some observations remain ambiguous, some are still being gathered, some of the outer worlds in the temperate lane have not yet been probed as deeply. The pattern is not complete. Science does not rush to close a case. But the results that have come back so far from the small rocky worlds closest to that other small red star keep pointing in the same direction as the results from Proxima Centauri b. Small, close, rocky, and mostly without the atmospheric signals we hope to find. Let me say that again, because it is the shape of the pattern, and it matters. Small, rocky worlds close to small, flaring red stars keep coming back quiet. That is not from one look at one planet. That is from many looks at many planets. Different systems, different research teams, different instruments on the same great telescope, different techniques for reading the light, and yet, again and again, the same kind of hush. Not always a definitive no, sometimes only a very thin maybe, but rarely, so far, a clear and confident yes. Rarely the strong, unmistakable fingerprint of a thick atmosphere on one of these worlds. Sit with that for a moment, because what it might mean is one of the more sobering possibilities in the entire modern search for life beyond Earth. It might mean that the whole category of nearest possible living worlds, the whole shelf of small planets crouched close to small red stars, is systematically less friendly to atmospheres than we hoped. That the same flaring, the same closeness, the same tidal locking, the same slow stripping across billions of years is happening again and again across many systems, quietly emptying planet after planet of the air they might once have held. That the habitable zones of red dwarfs may be lined with bare rocks and battered stones, temperate in temperature but empty of the veils of gas that any life would need. If that turns out to be the picture, then the nearest possible living world is not just far. It may not exist within any distance we could hope to reach in the foreseeable stretch of time. Let that land for a second. And yet, here is where I want to hold the both and truth again, honestly and carefully. Because science is never as one-sided as our first sadness wants it to be. The same pattern could also mean something else. It could mean that we are learning in real time what to look for, that we are drawing, planet by planet and silence by silence, a sharper picture of the specific conditions that let a small, rocky world hold on to its air. Not every red dwarf flares equally violently. Not every small planet forms with the same starting inventory of gases. Not every world sits at the same distance, or has the same interior heat, or the same magnetic history. Some may be more protected than others. Some may have started with more air. Some may sit slightly further out in the habitable zone, where the star's fury is less concentrated. And by studying the worlds that appear to have lost their atmospheres, we begin to understand the fingerprints of the worlds that might have managed to keep theirs. This is exactly what a maturing search looks like. It does not begin by finding the answer. It begins by narrowing where the answer could be. It begins by learning which possibilities to close and which to keep open. Every silent world helps us define what a not silent world would look like. Every bare rock teaches us what conditions strip an atmosphere and what conditions might have let one survive. The disappointments and the discoveries are the same activity seen from two sides. Both of these are true. The category of nearest possible living worlds may be quieter than we hoped, and the study of that quiet is teaching us, at the same moment, how to recognize the rarer world that might have kept its voice. The narrowing is not the same as the ending. The narrowing is how the search learns to see. And behind all of it, patient and unglamorous and endlessly careful, is the human work. I want to name that again, because it is easy to forget when the story stays at the scale of stars and planets. Somewhere on Earth, in offices and observatories and quiet rooms with too many computer screens, there are teams of people who have spent years monitoring these red dwarfs. Not 1 week, not one campaign, years. Watching the same stars again and again, catching their flares, measuring their brightnesses, tracking their tempers across time. Little by little, they build up profiles. This one flares this often, at this energy, in this range. That one is calmer. That one is more violent. That one produced a super flare last year that would have been catastrophic for any planet close in. These profiles are not glamorous science. They are the patient, quiet work of learning what our neighborhood stars are actually like, so that when we look at the planets around them, we know what those planets have been enduring somewhere else. Other people are building models, simulations of what happens to an atmosphere when a certain amount of ultraviolet light hits it, when a certain stellar wind pushes on it, when a certain flare arrives at a certain intensity from a certain distance. They run these simulations for millions of simulated years, for hundreds of millions, for billions, testing what different starting atmospheres would do under different star conditions. They compare the outcomes to what the telescopes are seeing. They refine, they rerun, they compare again. It is slow work. It is the kind of work that does not produce headlines. And it is the work that turns raw observations into meaning. Somewhere else again, still other people are cross-checking each result the telescope brings back. Independent teams processing the same data with different methods, seeing whether they arrive at the same conclusion. Skeptical eyes going over the analysis, looking for anything that could have been missed. Rival groups quietly agreeing over and over that yes, the signal is not there, or yes, the pattern is real, or no, this particular claim needs more data before it can be trusted. The picture that emerges from all of that is more reliable than any single announcement could be. It is a picture built by many hands, checked by many eyes, held to a standard higher than any one person could reach alone. That is, the collective, patient, self-correcting labor at the center of all of this. It is not one telescope. It is not one team. It is not one moment of discovery. It is a long, slow accumulation of careful looking, careful modeling, and careful cross-checking, spread across many institutions in many countries, all quietly working on the same question. And what this collective labor is beginning to tell us, quietly, is that the small rocky planets around small red stars are not the easy homes we once hoped they would be. That the nearest possible living worlds are not so easy to come by, that the search will be longer and harder and more careful than the first flush of discovery led us to think. Which brings us back, gently, to our specific planet. Proxima Centauri b is not standing alone in this widening picture. It is not one strange result, surrounded by many more hopeful ones. It is one member of a whole family of small close worlds around small restless stars. And that family, taken together, has been returning largely the same kind of quiet across many careful looks. The silence we sat with in part 4 is not the silence of one disappointing world. It is a note in a chorus of silences that is beginning to sound like something, not the sound we wanted to hear, but a sound all the same, a pattern, a shape of understanding forming out of many observations. That reframing matters, because it takes some of the weight of the disappointment off our nearest planet's shoulders. Proxima Centauri b is not the one that failed us. It is not a single sad result in an otherwise cheerful search. It is one honest voice in a chorus of honest voices, all of them saying the same quiet thing about the same kind of world. Small rocky planet, close to a flaring red star, no clear thick atmosphere detected. The message is not personal to our nearest neighbor. It is a message about the whole category. And carrying that message is not a failure, it is a contribution. So when you picture the red point of light on the imagined horizon now, picture it as part of a family. Picture, behind it in your mind, a scatter of similar small red suns spread across the local neighborhood, each with its own small locked planets, each of them being looked at, listened to, measured, modeled, cross-checked. Picture the many patient people working on this, in many rooms, at many hours of the day and night, doing their careful looking. Picture that our nearest neighbor is one voice in that chorus, quiet like the rest, part of what the chorus is teaching us. Its silence is no longer isolated. Its silence has company, and in that company, the meaning of the silence shifts. It is not the story of one small world that could not, on its own, be the neighbor we wanted. It is a piece of the larger story of what small worlds around small red stars generally are and are not, and might sometimes still surprise us by being. Let the pace slow now. Let this widening settle in you, the way a wider view settles when you step back from a painting and see the whole canvas. The nearest planet is still there, still turning, still huddled beside its restless red star, still probably locked and probably battered and probably without the veil of gas we hoped it might carry. Nothing about our specific nearest neighbor has changed while we have been widening the frame. What has changed is the frame itself. We are looking at it now, inside its family, inside its category, inside the pattern that many careful observations of many similar worlds are quietly assembling for us. And there is a small comfort in that, if you let yourself feel it. The comfort of knowing that our nearest world is not a solitary failure of hope, but a member of a class of worlds we are learning to understand better and better with every look. That its silence is contributing to something, that the picture it belongs to is being drawn patiently by hands that have not stopped drawing. Hold the red point of light in your mind again for a moment. But hold it now, knowing that it is one ember among many similar embers scattered across the local neighborhood of the sky, each with their own small worlds circling them, each being studied with the same patient care. It is still ours, in the small sense that closeness allows. It is still the nearest, but it is no longer alone in its silence. It is part of a family, and the family is teaching us, together, one honest, quiet finding at a time, about what the small, rocky worlds of the small red suns are truly like. That is where we leave it for this widening, the nearest but not the only, the quiet but not the isolated, the one we can see, held now inside a family of many, we can also at last begin to see. And when we come back to it in a moment, we will return to it one last time before the night ends. Now that we have widened the frame and set our nearest planet inside its family of small red suns and small close worlds, I want to bring us back in close to Proxima Centauri b itself, and hold something open with you that the science asks us to hold open. I want to sit with the possibilities that remain, not the loud possibilities, not the ones we started the night hoping for, the quiet ones, the narrow, careful, still-standing possibilities that even the silence from the great telescope has not fully closed. Because a night like this one can leave you with the feeling that everything has been decided, that the odds have collapsed to zero, that the door has swung all the way shut. And that is not quite what the science says. The silence we sat with in part 4 was heavy, and it was honest, and it points in a particular direction. But the silence is not a verdict of certain absence. It is a verdict of we did not find. And there is a real difference between the two. And I want to walk through it with you patiently, because the honesty of the science requires it, and because you deserve to know what remains genuinely open, even after all we have learned. Let me start with the humblest of the possibilities, the one that sits closest to the silence itself. When the telescope looked at Proxima Centauri b and did not find a clear atmospheric fingerprint, that finding rests on the sensitivity of the instrument and the length of the looking. The telescope is remarkable. It is the most sensitive instrument of its kind ever built. But even the most sensitive instrument has a threshold. There is a level of signal below which it cannot cleanly separate the fingerprint of a gas from the ordinary noise of the light. If an atmosphere is there but is very thin, or if it is composed of gases whose fingerprints are weaker than expected, or if there are high clouds and hazes drifting above it that flatten the light before it ever reaches our eyes, the signal might simply lie below what the telescope can currently pull cleanly out of the dark. That means it is possible, genuinely possible, even if not likely, that Proxima Centauri b holds a very thin atmosphere that we have not yet been able to see, not the thick, warm blanket we hoped for, not the heavy carrier of heat around the world that would soften the extremes, something smaller than that. A whisper of gas, a modest veil, wrapped around the planet, present but not thick enough to shout its presence back across 4.2 light years to a telescope that is only just barely capable of hearing at that level. If such a thin atmosphere is there, it would not make the planet the second Earth we dreamed of. It would not fill the day side with weather and the night side with warmth and the whole world with a gentle blue arch of sky. But it might still do something. Even a thin veil of gas can shield a surface from some of the radiation that a bare rock would receive full force. Even a modest atmosphere can carry a small amount of heat in slow, lazy drifts from the day side toward the night. Even a light blanket can mean a temperature difference between two sides that is measured in hundreds of degrees rather than in the extremes of a truly airless world. The thin case is not the hopeful case, but it is not the empty case either. It is a middle case, and it remains, quietly, on the table. Sit with that for a moment. Now, let me walk you across the surface again, the way we walked across it in part 3, but this time with an eye for one specific place, the ring of endless twilight. Remember it. The band that runs around the middle of the world where the red sun sits forever on the horizon, half up and half down, neither rising nor setting, simply held. On the harsh version of a tidally locked planet, the two hemispheres pull apart into cooked and frozen extremes, and the twilight ring sits between them as the border. But even on the harsh version, that ring is not cooked and it is not frozen. It sits, by the geometry alone, in the mildest place the world has to offer. Picture what conditions there would actually be like, in the harshest scenario, without much of any atmosphere. The star hangs on the horizon, red and steady, throwing its light across the ground at a low angle, the way a late afternoon sun throws light in the last hour of the day. Only this afternoon does not end. On one side of you, in the far distance, the ground stretches away toward the day side, growing hotter as it goes. On the other side of you, the ground stretches away toward the night side, growing colder as it goes. But right here, on the ring itself, the temperature is neither of those extremes. It is milder than the searing day, It is milder than the frozen night. It is not comfortable in any human sense, but it is less absolute than the other two sides of the world. Now add to that ring the possibility of that thin atmosphere we just imagined, that whisper of gas we have not yet been able to detect. The whisper of gas would concentrate its softest effects exactly where the temperatures are already most moderate. The twilight ring, in the presence of even a thin veil of air, could become the least brutal place on an otherwise brutal world. A narrow ribbon running around the planet, where the geometry and the whisper of gas together conspire to make one specific strip of surface a little less impossible than everything to either side of it. This is what astronomers sometimes call a niche, a place that is not habitable on its own terms, but that becomes a little more livable than everything around it, and that could in principle host something small and hardy. If something small and hardy ever managed to get started there. On Earth, we know of niches like this. Deep sea vents where life clings around the mouths of hot springs at the bottom of the ocean. Frozen soils in polar deserts where microbes survive at the very edge of what water can do. Cracks in rocks where communities of tiny living things persist for years without seeing the sun. Life on our own world has an extraordinary talent for holding on in places that seem, from the outside, unlivable. The universe has shown us, at least on this one small planet, that a niche is enough. Whether the twilight ring of Proxima Centauri b could be such a niche is a question with no confident answer. Probably not. The star is too violent. The atmosphere is probably too thin or entirely gone. The chemistry of the surface may never have had a chance to build the kinds of molecules that living things are built from. All of those probabilities lean against it, and yet the geometry of the ring is real. The mildness of that band is real. The possibility that some form of life could, in some form we cannot easily picture from here, have found a foothold on that narrow strip of the world is not zero. It is small. It is unlikely. It is not zero. There is another possibility, quieter still, that I want you to hold with me for a moment. On Earth, our biosphere is mostly a surface biosphere. When we picture life on our planet, we picture forests and oceans and skies full of birds. But there is also, beneath our feet, a whole other world of life, a biosphere that lives inside the rock. Microbes that live kilometers underground, in the pores between grains of stone, sipping at trickles of water, drawing energy from chemical reactions between minerals and dissolved gases. That subsurface biosphere is enormous. Some estimates suggest that a substantial fraction of all the living matter on Earth lives beneath the surface, in places we never see, in conditions no surface creature could tolerate. Life, once it exists, does not stay only on top. It seeps down into the rock and takes root there, and once it is there, it is remarkably difficult to remove. Now apply that idea gently to Proxima Centauri b. Even if the surface has been scraped bare by the flares, even if the atmosphere has been stripped almost entirely away, even if the day side is a cooked rock and the night side is a frozen one, and the twilight ring is only a little less brutal than either, there is still, beneath all of that, the interior of the planet. Rock, kilometers thick, insulating whatever might lie below from the violence at the top. If life ever arose here, deep in the planet's youth, when perhaps the atmosphere was fuller and the surface less hostile, Some of it might have slipped downward into the rock, into the warmer, more stable, more sheltered layers, and might, in principle, still be there, not visible from any telescope we have or will build, not detectable from a distance at all, simply present, a quiet subsurface biosphere on a battered world, hidden by kilometers of stone from the star that stripped its skies. I want to be careful with this idea because it is easy to fall in love with, and it is not the most likely case. There are many reasons to think Proxima Centauri b never got far enough along for life to have arisen at all. The early violence of its star may have prevented the chemistry from ever getting started. The planet may have been battered too hard, too early, and never had a stable enough surface long enough for anything to take hold. These are real objections. They are honest ones. But they do not close the door, and the door of a subsurface refuge, invisible from here, is one of the doors that remains open. Not likely, not probable, but open. And honesty asks us to keep it open, quietly, in the room where our thoughts about this planet live. So we hold all three of these possibilities together. A thin atmosphere below our current detection threshold, a twilight ring that might be less brutal than the rest of the surface, a subsurface refuge insulated from the violence above. None of them is likely. None of them has evidence pushing it toward likely. All of them remain, in the strict language of what we actually know, possibilities that have not been ruled out. This is the both and truth I want you to sit with. All of these possibilities are unlikely, and all of them are still open. Both of these are true at the same time. The unlikelihood does not close them. The openness does not brighten them into probability. They exist in a quiet middle place where honest science keeps its unresolved questions. And holding them open, gently, is not the same as clinging to false hope. It is the same, exactly, as respecting what we do not yet know. It is what a mature science does with the questions it cannot yet answer. Now let me turn us, gently, toward the future. Because the story of Proxima Centauri b is not closed. It only feels closed because we have looked once, carefully, and heard a quiet answer. But the looking is not going to stop. Right now, on Earth, on high desert mountains, and on remote plateaus, human beings are building telescopes that will make the great instrument beyond the moon look small. Gigantic mirrors, tens of meters across, wider than a small house, ground and polished into shapes so precise that the deviations from perfect are measured in fractions of the width of an atom. Ground-based telescopes with light-gathering power beyond anything ever built. They are years from finishing, some of them. Others are closer, but they are coming. They will open their eyes on the sky in the not-so-distant future, and when they do, they will be able to look at nearby planets with a sensitivity that the current generation of instruments cannot match. Among the specific targets those new telescopes are being designed to observe, Proxima Centauri b sits high on the list. It is the nearest. It is the most accessible. It is one of the specific worlds these instruments are being built to characterize more deeply than anything we can currently do. They will not just be able to look for thick atmospheres. They will be able to look for much thinner ones. They will be able to search for specific gases at concentrations far below our current threshold. They will be able to test, in ways we cannot yet test, the possibilities we have just been holding open. Whether a thin veil of gas is really there, whether the twilight ring shows any softening, whether the fingerprints of chemistry we would associate with life exist at any level we can detect. The telescope beyond the moon has told us what it could tell us. It has given us the first honest answer. The next generation will ask the same question with finer ears, and after them, the generation after that. This is how the search actually works. Not in one look, in many looks spread across decades, each one refining what the last one saw, each one narrowing or widening the possibilities a little further. Proxima Centauri b will be looked at again, and again, and again, by instruments we are building now, and by instruments we have not yet imagined. The planet is not going anywhere. It will still be there, turning in its silent orbit when the next telescope opens its eyes, and when it does, we will point that new eye at the nearest planet, and we will listen again, and we will see what the light has to say this time. Hold that with me for a moment, gently. The story is not closed. It is only currently paused at the honest, quiet answer of the first careful look. The next chapter has not been written. The possibilities we have just walked through are not confirmed, and they are not ruled out. They wait for better instruments and more patient looking. They wait for the same patient human labor to widen and refine and check itself, the way it always does. And Proxima Centauri b waits with them, turning slowly, unchanged by any of our expectations. So the awe, if we let it, can settle into a quieter shape now. Not the loud awe of a possible living neighbor, not the sharp disappointment of a dead one, something in between. The awe of a world that we know a great deal about and still do not know completely. The awe of a planet whose specific quiet has taught us so much, and whose remaining possibilities, however small, still hold open a small door in the far corner of the room. The awe of a search that is patient enough to keep looking at the same world again and again, honestly, for as long as it takes to be sure. Let the sentences slow now. Let the room grow a little quieter around you. The planet is still there. It is still turning. It is still the nearest neighbor we have. The odds of anything living on it have narrowed to something small, but small is not the same as nothing. The next look might not change that. The next look after it might not either. But somewhere, in some coming year, another eye will be opened, and this small locked world will be looked at again, and the light will speak, and we will listen, and we will learn what there is to learn. That is the shape of the science. That is the shape of the searching. And Proxima Centauri b, quiet as it is likely to be, remains capable of surprising us, however unlikely the surprise. A thin atmosphere we missed, a gentle band we have not yet resolved, a refuge beneath the rock that we can only imagine. None of it likely, all of it possible. The planet waits, without needing us to hope for it, without needing us to grieve for it, simply turning, as it always has, around its small red star. Hold that image with you now, gently, as we get ready to walk the last of the way home. The locked world still turning, the red sun still burning, the thin, unlikely possibilities still open. The next generation of instruments still being built. The story still not closed, only paused, only waiting, only for tonight, quiet. Come back with me to the beginning. Come back to the red point of light low on the imagined horizon, the single small ember burning in a sky full of colder stars, the nearest sun in all the heavens above you. That is where we started tonight. Long before the star had a name in our story, before we spoke of flares or locked faces or silences gathered by a great instrument beyond the moon. Just a point of red light, quiet in the dark, closer to you than any other sun in the sky. Picture it now, softly. Let it settle back into your mind, the way an image settles into a still pool. You know more about it now than you did an hour ago. You know that it is not the calm, steady fire our own sun is. You know that it is small and red and restless, and that it flares again and again across the long stretches of its own time, throwing out bursts of radiation and streams of charged particles into the space around it. You know that pressed close against it, closer than any planet in our own system stands to our own sun, is a small rocky world roughly the size of Earth. You know that world by name now, Proxima Centauri b, the nearest planet beyond our own family, 4.2 light-years away, a distance that no human journey could ever cross. And you know, now, what almost certainly waits there, a world locked in place, one face turned forever to the red sun, one face turned forever to the dark, a day side held in unmoving glare and a night side held in unmoving cold, a thin ring of endless twilight running around the middle, where the sun rests forever on the horizon, neither rising nor setting, and most likely, though never certainly, a surface without a real atmosphere to soften any of it. A world scraped bare by the long violence of its neighborhood. Stone and radiation and silence, held together by gravity, turning slowly in its orbit as it has for billions of years. That is what you now know sits above you, low on that imagined horizon when you picture the red point of light. And here is the strange thing. The knowledge does not diminish the light. It deepens it. Before tonight, when you looked at that little red star, if you looked at it at all, you were looking at a bare fact, a bright dot, the nearest sun, a name and a distance, and nothing more. Now, when you picture it, you are looking at a whole world. You are looking at a locked face. You are looking at a divided planet. You are looking at billions of years of quiet endurance, and at the long, slow scraping of an atmosphere that may or may not have ever really taken hold. You are looking at the small stone that our finest instrument was pointed toward, and at the honest quiet that came back from that looking. You are looking, in one glance, at everything the night has walked you through. The light is the same. Your knowledge of the light has changed, and the change makes the light heavier and richer and more precious, not less. Hold that for a moment. This is the shape of every honest look at the sky. The things you learn do not empty the sky. They fill it. They give the points of light their weight. They turn what were once faint, anonymous dots into places, specific places, each with its own conditions, its own history, its own quiet story. Even the empty ones, even the bare ones, even the ones that turned out to be less than we hoped, they become themselves, and themselves is more than we started with. That is the small, quiet gift of this kind of learning. It does not fill the universe with what we wished for. It fills the universe with what is actually there. And what is actually there is, in the end, more interesting than any wish. So let me gather up, gently, the things we have carried through this night, and set them down together so that you can rest with them all in one place. We have walked through scale, through the strange truth that 4.2 light years is impossibly far and impossibly near at the same time, that the nearest planet to Earth is a place no human being can ever reach, and that the scale of the galaxy is such that this counts as close. We have felt what a light year is by imagining a walk we could never finish, and by placing our own bodies inside the geometry of a distance that would swallow all of history without noticing it past. We have walked through patience, through the long, slow work of generations of astronomers who mapped this corner of the sky before there was any planet to know about, who measured and remeasured, who added to a ledger that most of them would not live to see completed. Through the decades of design and building that went into the telescope now stationed beyond the moon, through the tens of thousands of hands that shaped it, through the careful listening it did on our behalf. Patience as a form of respect, patience as a form of love, even if the word is not too large for what people spend their lives doing when they build instruments to look at faraway stars. We have walked through the gap between what we see and what is. We started with a point of red light and ended with a whole complicated world. And the difference between the two is the whole space that science lives in. The first look is never the true look. The apparent thing is never the whole thing, and the honest work of understanding is the work of closing, slowly, patiently, the distance between what a thing seems and what a thing is. We have walked through smallness, human smallness, the smallness of a species that cannot travel 4 light years, cannot in any lifetime reach even our nearest neighbor, cannot in fact reach much of anywhere at all in the vastness of the universe. But we have walked through that smallness carefully. We have not called it insignificance. Smallness is not the same as insignificance. Smallness is a situation. It is where we happen to stand. It does not mean that what we do from that standing does not matter. It means only that we do it from here, from this small world, with these small instruments, across these small lifetimes. And what we do from here turns out to be enough to look at a planet 4.2 light years away and learn something true about it. That is not insignificant. That is astonishing. That is a species doing something with its smallness that its smallness would seem to forbid. So the smallness is real, and it is also in its way wonderful. Both are true. Both fit inside the same quiet frame. Now, let the pace slow. Let the sentences shorten. Let the room in which you are listening tonight begin to settle. Proxima Centauri b is still the nearest planet to Earth. It is still our closest neighbor. It is still worth the looking. Nothing that we have learned tonight has changed those 3 things. The odds of anything living there have narrowed. The atmosphere is probably not what we hoped. The surface is probably harsher than any place we can picture. But the planet itself is still there, still turning, still huddled against its small red star, still crossing the same orbit every 11 days that it has crossed for a very long time. Still ours, in the small sense that closeness allows, still the nearest. And the red light in the sky, that single quiet point, is still what it always was, a small sun, a neighbor, a place we can see but never visit, a place we can measure but never touch, a place that is real in every way that matters, whether or not anyone is there to walk its surface. Picture the light again, softly. Do not think of it as a lost hope. Do not think of it as a candle blown out. Think of it as a small red ember, patient, burning, turning around itself in the dark. The kind of ember you might see across a field on a quiet evening, not calling to you, not asking anything of you, simply present, simply there. The planet turns beside it in its long silence, and the silence is not a sadness, the silence is a fact. The planet has been silent for billions of years and will be silent for many billions more, and nothing that we do or do not learn about it changes any of that. It is going about its own long existence. It always was, it always will. You are here. You are on Earth. You are on a world that is warm and blue and turning under its own atmosphere, held safe beneath your own steady sun. You are inside a room. You are wherever you are as you listen tonight, in whatever quiet place you have found. Above you, somewhere, is the sky. And in that sky, if you could see it, is the small red point that we have spent the whole night thinking about. Let it be there. Let the knowledge you now carry about it be gentle rather than heavy. Let the quiet of that distant world become the quiet of your own room. The nearest planet to Earth is not alive, almost certainly, but it is real, and it is near, and it is ours to look at. That is enough. That has always been enough. Somewhere above you, low on the horizon of a sky you may not be able to see, the small red star is still burning. It has been burning since long before there was an Earth. It will burn for longer than we can meaningfully imagine. And around it, in its quiet ellipse, the small locked world is still turning. One face to the light, one face to the dark. A thin ring of twilight around its middle, where the red sun rests forever on the horizon. Picture it once more, and then let it rest. Let your thoughts slow. Let the last of the day fall away. Let the small red ember stay lit in the corner of your mind, patient and undemanding, a nightlight burning at an impossible distance, the nearest light in all the sky. There is nothing more you need to do tonight. There is nothing more the planet needs from us. There is only this quiet room, this quiet body, this quiet sky above you, and somewhere in that sky, faint and steady, the nearest neighbor we have. Sleep well beneath it.